Started.
Good evening, everyone. Welcome to the Centenary Celebration of the Department of Mechanical Engineering, IIEST Shibpur. Today, we are here for the 19th Centenary Lecture under the Centenary Lecture series by our Honorable alumnus, Dr. Prabodh Kumar Maji, on the topic Renewable Energy for Sustainable Development Objective, Current Status, Future Prospects, and Challenges. Today's session will be chaired by Professor Gautam Biswas. He is a JC Bose National Fellow and Professor in the Department of Mechanical Engineering, IIT Kanpur, and former Director of IIT Guwahati. Sir, over to you.
Thank you very much indeed. Thanks to all others. My reverence and respect to Achyuta, Ashokda, Dr. Bhattacharya, and all dignitaries. Also to the organizers, head of the department, Vidyut, everyone. I have been given this pleasant task of introducing Prabodh. Incidentally, I am very closely linked to Prabodh because of our academic relationship. First, let me let me formally introduce Prabodh. Dr. Prabodh Kumar Maji obtained his bachelor's degree in mechanical engineering from B College Shibpur. That time it was under Calcutta University in 1984. He completed his MTech in mechanical engineering in 1986 from IIT Kanpur. Subsequently, he achieved his PhD in computational fluid dynamics and heat transfer from the same institute in 1998. Dr. Maji joined Mech India Limited in 1986 as a management trainee. Actually, his PhD was on leave from, during his PhD, he was on leave from Mech. He rose to the deputy general manager, finally general manager and senior general manager in Mech Ranchi. And he retired as Chief General Manager Energy and Head of Power Strategic Business Unit. Dr. Maji provided engineering and consultancy services in various power generation projects pertaining to thermal, hydel, and non-conventional energy associated with ferrous, non-ferrous, and power industries. He has vast experience in basic design and detailed engineering, including system configuration, conceptual plant layout, preparation of process flow diagram, uh, techno-economic feasibility reports, detailed project reports, and technical specification, cost estimation, and everything related to project engineering, so to say, commissioning and post-commissioning services. Dr. Maji has also worked on several other special projects, including preparation of roadmap document of 27 into 24 into 27 power for all for 9 states, which was monitored by Ministry of Power. He has served on many committees as chairman, convener, or members, including Tidal Monitoring Committee, in Sundarbans, Non-Conventional Energy Sources Committee, formed by Bureau of Indian Standards, and Indian Society of Heating, Refrigeration, and Air Conditioning Engineers. He is a fellow of the Institute of Engineers Dr. Maji has several research papers to his credit, published in international and national journals and several conference proceedings. So this is Prabodh's formal uh, um, formal introduction. I would like to add little, if you allow, informally. Uh, I have already said that Prabodh did his PhD from IIT Kanpur. I am very fortunate that Prabodh did his PhD under my guidance. And in order to really what Prabodh did, I will take little time and introduce that. Ashokda knows, because obviously Ashokda was here, and he knows about Prabodh's brilliance. Probably you can see a picture. This is a hydraulic power plant overall overview. This is basic schematic of hydraulic power plants. As you know, dams are located much above, in a little different place, from where through, several ducts and manifolds, water is supplied to the basic plant. And where this is schematic of the plant. This is the location of the turbine. This is draft tube, etc. And this is the overview of a plant. And so, Dr. Murli, I will just call back to you. I'm in a meeting. Hello. So now this is Francis turbine. And as I said, that huge amount of water comes, and as you can see, water is distributed radially. And this is a runner, these are aerofoil blades. And for a smooth entry, the vanes are used. Many of us have done, solve problems in undergraduate days that about these vanes. Our vanes are nothing. They basically give direction to the water to smoothly match to the aerofoil profile of the rotor blades. And so I'll stop here. Basically, this flow with a huge Reynolds, mass flow rate, Reynolds number, and you can see the flow geometry is extremely complex, and here it is all cluttered with guide vanes and followed by the runner. This geometry, why I showed, basically this is the geometry that was the challenge in front of Prabodh when he started his PhD. We were all beginners in our academic pursuit, and I got this project from BHEL. BHEL is the global player in all fronts of energy, but especially in hydropower, because competitors of BHELs are only three. Means all are global leaders: General Electrics, Siemens, and Mitsubishi. And they used to, their effort was to compete for global tenders. And for these global tenders, as you can see, this spiral casing is extremely important because all reaction turbines, the main pressure is held by the, spiral casing. So that, usually Francis turbine or Kaplan turbines are, 50 to 70% reaction turbine. This reaction and the lift per aerofoil blade is generated because of pressure difference. So this entire design is very complex. When we started this work, somehow formulation was such that it was to be done using finite elements. Usually, all of you know, in fluid mechanics, we use either, finite difference or finite volume because of some specific advantages. But finite element, despite having tremendous power, was not being used. And this was a situation till end 80s. And Prabodh started his PhD beginning of, or you can say 94, 95, around that time. So it continued globally. And globally, finite element was a great tool for civil engineering people, but not for, and for mechanical engineering people who are in solid mechanics, but not for fluid dynamicists. The reason is very simple, that finite element is extremely accurate mathematically. Within each element, the basis functions are such that every function, every variable is interpolated with absolute accuracy. But in flow field, that accuracy is harmful because it has a flow bias. So field has to be biased with the flow direction and for flow velocity, which is innate with finite volume method, but that is not built-in advantage with finite element. And globally, people were trying to adopt finite element for fluid flow, and people were successful for up to low Reynolds number. I mean, up to Reynolds number of 400, 500, but not for high Reynolds number. And Prabodh's application, all of you can see, the range of Reynolds number started from 50,000. It was 50,000, 60,000, 70,000 and above. So for this high-speed flows, finite elements were to be reformulated. Usually all finite elements are based on Petrov-Galerkin method. So to induce the flow bias, it's a method called streamlined upwind Petrov-Galerkin. In late 80s, it became almost in a decent shape, got a decent shape by Tom Hughes in Stanford University, and some of his students. One such student was Irfan Tejduiyar, who was in University of Minnesota, and our national level, one of the very well-known names, Professor Sanjay Mittal. He did his PhD under Professor Tejduiyar, and around the same time frame, he returned to India. And I was, in a very modest way, trying to do that with using Prabodh's expertise, because Prabodh was mathematically absolutely fantastic. One cannot imagine what was his mathematical foundation, especially being trained in an engineering college. My predecessor, uh, who is also no more, Professor Vijay Gaur, he left IIT Kanpur and he was in US. He wrote a mail to me that, Gautam, you are lucky that you have got Prabodh as a PhD student, because I have, in my stay in IIT Kanpur, I have never seen a student mathematically so strong. So when I gave this problem to Prabodh, Prabodh was also little in an awkward position, because how to give this upwind bias and adopt streamline upwind Petrov-Galerkin method. We read some of the papers of Irfan Tejduiyar and Tom Hughes. And then our mathematics department had a very well-known expert, Professor P.C. Das. We went to P.C. Das. He was offering a course for the PhD students. Prabodh and I started attending that course. I did not continue for long, but Prabodh continued with that course. And in that course, Prabodh mastered even Sobolev space, which are dream of mathematical scientists. And Professor P.C. Das told that, Gautam, you are working with a fantastic person, and he is the right man, but you attempt 2D version of it first, then go for 3D. So when I told Prabodh this, was said that, sir, I have only 2.5 years leave, I can extend it to 3 years. So I have no time to try with 2D, I'll directly jump on 3D. And really he did that. And it was a great success. We had excellent papers. Some of them are very well referred, but this area is not so popular in a way, this hydro turbines. That is why its citation has not skyrocketed, but finite element people honor this work, and they often refer for their SUPG formulation. I have only praises for Prabodh, because the way I have been benefited, and I have also learned a lot through his mathematical implementation skill. It was simply fantastic. So with this, I will stop here. I'll not prolong long. So you listen to Prabodh. Unfortunately, Prabodh will not be able to show his mathematical, talent through today's presentation, because Prabodh could not continue with his, mathematical abilities for long. He had to really be a man perfectly suited for a consultancy firm and industry needs. So he did a few other things together with his innate talent in mathematics. We'll listen to those different aspects. Thanks to all of you for your patience. I took a little longer time to introduce the speaker, because I'm very passionately and what to say, gratefully involved with Prabodh's excellence. Thank you very much. Prabodh, please start. Probably Prabodh is muted, or
Okay. Thank you, sir, and for the compliment. And I am also good evening to all my seniors, and also good evening to my all other uh, basically college mate. We are very proud of this college. So when I got this opportunity, I think this was the opportunity for me to speak in this occasion. I have taken a topic. I could have taken some other topic, but I thought that renewable energy is a very important topics in today. So it needs awareness. So I am not going through very details on the things, but why it is required. That is my emphasis, and what is our commitment in the forum, in the international commitment, and what are the actions we have taken, and how we are proceeding in this direction, and what are the challenges. Basically, I am going to speak on that. Next slide, please. Next slide. Our excuse me. Uh, my flow presentations will be first. I will talk about the objective, then what is the present status and future projection, and which compel us to worry today, and which are the key drivers to go for a alternate energy sources, and then present status and future potentials of our renewable sources of energy. Then some key development about some renewable energy. I cannot cover all the things, and with their legal provision. And then the very upcoming things, the key development in green hydrogen. I will talk something about that. And energy storage is also equally important, because this renewable energy is a very load which is very fluctuating. That depends on the environment. So basically, earlier days, our generation was controllable, but our basically load was not uncontrollable. But now is both the thing. Our generation is also, you do not know when you will generate. This totally depends on the environment. Okay, next slide. and then finally I'll talk about the key challenges. So our primary objective in deploying renewable energy is basically to continue or to accelerate our development, which we are expected by 2040. We are going to be 8.27 trillion economy. And so our energy security is a very prime importance. Uh, and that is the reason why we should go for because that basically that is fixed resources are limited, so we have to think about other resources, and then we have to ensure that a sustainable, affordable and reliable energy to all of our citizens, and also we have to reduce our import duty. Then I'll show some slides in it, and how to mitigate the climate change basically because of the fossil fuel burning and other thing. And finally, we are supposed to fulfill our international commitment. This is a basically legally binding commitment, and how to attract our private and foreign investment in this sector. Okay, next. Next. So here just today we have a installed capacity of around 4 lakhs megawatt. Out of that 4 lakhs megawatt, that 59.1% is from the fossil fuel and 40.9% is from the non-fossil fuel. Now non-fossil fuel means the nuclear is also included in the renewable. Here I would like to say that large hydro was not part of the renewables earlier, but we have a committed in 2015 that we have to meet the minimum 40% requirement of a total energy from renewable sources or non-fossil sources. So government of India decided large hydro to include into the renewable, because all other country, their large all hydro are under renewables. So that is the reason. So, and we are supposed to achieve this 1,75,000 from renewable by the end of 22, and hopefully that will achieve. Next. This is our total generation from basically, no, this is, sorry, this is from all sources. This is all sources, not from renewable sources. This is from all sources generation. So these are the generations. It is, you can see that during the COVID period, our requirement was reduced, but now it has increased to a level of quite high. It is almost, this is a billion, 1,500 billion unit. Okay, next. Now you can see this our energy requirement. Here I would like to say something. You see that 2000, this is the current year, last year, our energy requirement was something 13 lakh 75,000 million unit. And we have a shortage of 0.4%. And similarly, we have a peaking requirement of something 2 lakh 30, that is 2 lakh 3,000. So there's a shortage of 1.2%. And but we are generating something 14 lakh 90,000. Now here, basically sometimes we see that this basically shortage. So why there's so much load shedding, other thing is happening in many places. So for each state has a different kind of requirement. When we are doing the basically planning document for different states, what we found that particularly for the state like Haryana, Punjab, which are basically mainly power requirement was during the cultivation time, and their load varies from a 14,000, 15,000 megawatt during the cultivation time, and other time it reduced to a 7,000 megawatt. So what we have observed from their infrastructure, whatever the installed capacity, whatever the capacity they have already tied up with the central agency, we have seen there is a 35% of almost energy is a surplus, or there is some shortage of peaking. So that was a one issue. But whether the Gujarat is the industrial state where there is a basically the peaking shortage and as well as the energy shortage are low. This is because the load state load factor, which vary state to state depending on the what kind of basically activity they are doing. So Punjab and Haryana, they have a load factor is something 55-60%, whereas the load factor is of Gujarat is something 80%. So that is the reason of this thing. So this energy is a requirement, but still we have a deficit state, we have a surplus state. So that is a now, because of the national grid, that requirement can be met. Now we have a estimated that by 2030 our requirement will grow. Basically, our projected requirement, that will be something 25 lakhs from a 13 lakhs from a 13 lakh 75,000. So it is almost 83,000 more. So we have to think about how we are able to go into this energy. And we have also committed that this 50% of the energy will made from the non-fossil fuel. Now, the renewables are basically their load factors is very low. Their capacity utilization factor is very low, hardly 19%, 20%, this kind of. So you have to build to just basically meet a 100 megawatt coal base. You have to build at least 5 times, 6 times more capacity to get the same energy from a solar or wind and other kind of thing. Okay, next. Okay. This is our projected energy requirement. This is as per the energy forecasted by international energy organizations, associations. So you can see that India is basically, these are some major economies. Now India is going to suppress the European Union. That time the UK was part of the basically European Union. So it is suppressing that figures. And our growth of energy requirement over the period of 2016 to 2040 is 4.2%. It is highest among all the four. So this is one thing. There's another thing, that how we are going to meet this energy, that the primary energy, that your different sector like oil, gas, coal. Still, you can see that in the year of 2016, we have a hardly 2%. Basically, we are meeting from the renewable. Now that renewable is growing as a 12%. Now, so this figure, in fact, the present basically commitment or present basically installation capacity, or what we are going to achieve, we are going to meet, even this will grow even further. I think so it can grow even 15, 16%, 20%. And you see, during the year of 2040, it is just after basically coal and oil. So still coal will be a major energy source even in 2040. So we have to implement some new technology so that we can reduce emission from those plants. Okay, next. And another things you can observe, that the growth of basically primary energy and growth of electrical energy, it is basically double. The electrical energy is growing as double than the primary energy. So basically, that is the reason how we can meet the electrical requirement, that we have to think and we have to find out the resources which can meet this requirement. Okay, next. This is basically India oil and gas scenario. So you can see, I'm not going to tell something, because our almost 85% we are oil import dependence. That is the huge cost to the economy. Now you can see our import bill is almost $120 billion. So it is basically and this is because of the rise in oil price. And now next year it may more. I do not know when the oil price is going to down. So our reserves are very low. These oil reserves are very low. So this is one thing. Similarly, our gas reserves we are 50% of the gas we are basically importing from importing. So our total, and we are the third largest importer of oil at this moment, and then oil and gas both. And then India net import bill is basically almost $125 billion in the last year, in comparison to only 71 the previous years. Previous year, because oil price was very low because of the COVID, and that was the reason. Otherwise, our import bill is increasing day by day because of the oil price and other things and requirement. Okay, next. You can see that our resources are limited, particularly fossil fuel. If we do not import, and if you use that proven reserve, so these will last only for 3 years. The crude oil what we have, and natural gas will last for 22 years, and the coal will last for another 112 years. So this is the scenario. Even we can thought about oil and gas in next 50 years, even in the world. So this is the scenario. Okay, next. And India is another thing because our load center are far away from the basically resources. So these are the zone where the hydro resources are there. This is the gas zone, and also this zone, and this is the coal belt, some MP also, and Orissa. So basically, our load center are far away: Mumbai, Delhi, Bangalore. These are the load center. So we need a very huge infrastructure in terms of transmission distribution system, and which also contain losses. So this is also one of the point that we need very good infrastructure, and that will basically so that I can reduce the losses in the during transmission and distribution. Okay, next. Now, what factors basically? So, what factors will compelling us to worry? One is the volatility in the price in the market. There's a political unrest that you know in the oil producing country, and sometimes last year there is a natural disasters happen in the Middle East, and because of that, lot of oil productions was stopped for quite some time, and during time the price was spiked. And also there is a cartelizations among the coal producing country. That is also another, and because of that, the price is increasing. We have a energy security issue because you know that we have limited resources. Then import, we are basically unstable part of the world that we are taking. Something is happening all the time. Then we have a widening of demand supply gap, and our economy is really vulnerable because our economy has to grow. So we need energy. So definitely we are, and how to reduce the import cost, that is very, very important. And basic concern the environmental issue from the burning of fossil fuel, and then because of the human activity and the urbanization, a lot of deforestation is taking place. So that is also, so those are the carbon sinks that is reducing, and so in effect basically there's a effect of global warming. Next. So this is the basically what climate change that well everybody knows how it has happened. Current status from our basically pre-industrial period, that is this period, the temperature has already increased, and our sea level is already increased, and it is expected that by another by end of this century this is going to increase huge. So our commitment in the International Forum Paris Agreement, it should be within 2 degree the temperature rise. Otherwise, it will be a really problematic. So this commitment, each country has to be, entire world has to be carbon neutral by 2050. That is the commitment. But now it is not possible. What is that? I will say later on. And the temperature, then if it is not done, then the temperature will not be restricted, increased by 1.5 degree. What we thought about from with respect to the pre-industrial period, and our 80% emissions is coming from the carbon dioxide. Basically, is coming from the fossil fuel consumption. So this is also worry. Okay, next. So these are the basically you can see the potential effect, this temperature, precipitation, and then sea level. You have already seen that the frequent storm is particularly Bay of Bengal. So these are the basically effect of high temperature, precipitation, and the hurricane. So these are the various effect is happening. So we should be worried about that. How we can save our world from this effect. Okay, next. This is the basically if you see the global carbon footprint of top 5 nations, there is basically India is in a position of third rank. So this is our total emission. Now in terms of per capita, definitely we are position is 110 because of our population. So and but this is going to increase because of our economic development. So that is the main thing. So what we have committed in the COP26, basically the conference of parties 26 at Glasgow climate summit, that India should be carbon neutral by 2070. So now few countries they are already carbon negative. So but India has to be carbon neutral by 2070, and to achieve that one, so we have targeted by 2005 35 gigawatt. That means 5,35,000 megawatt from fossil fuel sources. Nuclear component will be very less because it requires lot of time to develop. So it has to come from solar, wind, and other sources. Even large hydro is not going to contribute much, because that also takes a lot of time, and development has a lot of social issue. And then we have also committed that if it goes as a business as usual scenario, then will from a 2.4 basically billion ton to 4.48 billion ton. That will basically that will be generated. But we have committed that we'll reduce that thing by 1 billion ton. So our target is to achieve 3.4 billion or gigaton. That sorry, gigaton that time. So this is another commitment we have made. Also, we made another commitment that our carbon intensity of the economy will be less than 40%, because different sectors. So it is not only concentrating on the power generation, we are concentrating also various other sectors like transportation, other, even the steel industry we have seen. So we are targeting everywhere, so that how the reduction, carbon dioxide emission can be reduced, so that we can achieve all these figures. Okay, next. These are the various key drivers for why you should go for alternative energy sources. Already there is a oil crisis in 70 and subsequent Gulf War. Now recent war between Russia and Ukraine also, we have seen what kind of price jump and what kind of geopolitical scenario in the world. Then limited resources that we have talked, energy security is very important for our economic development. And then there are a lot of international mandate happen. The most important mandate is Paris Agreement. That is a forward Kyoto, but now it is a basically Paris Agreement. And then this finally, recently in last year, it has happened in the Glasgow, UK, where we have made a lot of commitment, where all this commitment, what we have told that we have made. So to achieve this one, India has taken a lot of initiative, lot of policy initiative we have taken. So these are the policy initiative. Most important policy is the Electricity Act that has happened. The national tariff policy, this happened. Okay, next. This is the National Action Plan for Climate Change, then solar mission. And for the individual sector, we have created, and very recently, even 18, we have given a wind solar hybrid policy that we have given, and we have given a repowering of old, basically old wind farm. That we have also policy has driven. And finally, the green hydrogen policy of these 22. This is a very important policy, because India want that India should be a green energy hub, and we are ultimately planning to replace all our oil export other thing by utilizing the green hydrogen. Okay, next. So this is the Electricity Act, is a various provision. I'm not going to talk much. It is known. It is RPO obligations given the tariff regulations. This provision was made. The National Electricity Policy, tariff policy, and national policy permitting. They alone, even individual can generate power, renewable power, and they can use it. So that was permitted in this policy. Okay, next. Then we have another tariff policy, that is the RPO, the renewable purchase obligations was made. That is the reason this sector is developing. And then basically State Electricity Regulatory Commission, they have to fix the tariff, and based on that, power sector should operate. And then all the DISCOM, they have to purchase the RE through competitive bidding. And our long-term RE need, they should achieve the basically compete with the all other sources of like fossil fuel, other things. Now, one thing I just tell one to you, that renewable sources energy, basically now the wind, solar, the price has reduced even 2 rupees 50 paisa. Whereas recently you might be saying that coastal some power plant, the cost of generation is coming almost 7 rupees, 6 rupees 50 paisa. So we, although our tariff parity was supposed to be achieved in 2022, that we have achieved in 2017, 18, and now it is basically reducing day by day. So this is because of the policy initiative and other things we have taken. Okay, next. This is basically National Action Plan. It was made on 2008 to meet our requirement. So the RPO, basically the RE RPO, that is Renewal Purchase Agreement, that was fixed that minimum 15% has to be purchased by 2020. And but it was now in the amended tariff policy, it was fixed much higher. Now it has reached to a level of 21%, and out of which 50% has to be purchased from solar. So this is the kind of, although particularly that our renewable progress and our earlier achievement is really, really commendable. So this kind of things basically we are able to achieve. Similarly, our target was 45,000 by 2050 and additional 20,000, but we have targeted 1,75,000 megawatt by 2022, and that we are going to achieve also. So that is another policy. Okay, next. Our national solar policy 2010. So that time it was basically tariff parity was supposed to be achieved by 2022, which we have achieved in 2017 itself. And then our target was 20,000 megawatt of solar grid project. So that was changed to 1 lakh megawatt, and we have already achieved 55,000 megawatt, and we are expected to reach this level almost 70,000 megawatt by this year end. So our achievement is almost 3 times what we thought about during that point of time. Okay. This is the basically different renewable energy sources. Already I have told that this is the capacity building. Now you can see we have told, yeah, against 1 lakh we have achieved this 53,000, almost 54,000, and at the year end we are expected to achieve around 70,000. So we are going to miss 30%. And similarly in the wind we have targeted 60,000. So we'll be able to achieve something 45,000. So we are miss also here. But our, because of addition of hydro, so our total achievement will be able to make. Now you can see our total assessment till today, it is more than 13 lakhs megawatt. So that is the thing, and that too with a wind we have considered at the height of 80 meter. Now wind turbines are coming with a hub height of 120 meter, that high, and each wind turbine, basically those who are offshore wind turbine, that is coming almost 14 megawatt, 15 megawatt single turbine, going to generate almost 74 gigawatt hour. So this is the kind of development has happened. So it is, and also we have a offshore wind almost 2 lakh. This is as per the World Bank report, and that will be floating as well as fixed foundation type. We have a tidal also. The majority of tidal basically in Sundarban area, that is 9, and majority is in Gujarat. So there was the one project document. I was also involved that project. It was a 900 megawatt tidal project that was supposed to be built. So some RFP document was prepared in something 2004-5, but because of the grid issue and the cost issue, that has not taken up. And this project basically very ideal for, and so this is going to come definitely in Gujarat. I do not know what is going to happen in Sundarban. Okay, next. This is the basically wind potential that I've already declared. You can see that mostly majority of 7 states basically that is the wind potential. So out of at a 100-meter hub height, you can see that out of 3 lakh 20,000 megawatt. This is basically hardly majority is in the state and hardly few percentage in other state. So these are the state where, and this is shown the basically the wind potential zone. Okay, next. Now we have given different policy development for the wind power. So national offshore wind policy has come in 2015. So our target was 5,000 megawatt by 2022 and 30,000 megawatt by 2030. Now although basically 1000 megawatt project document was issued in 2018, but it has not taken up because of its high cost. Now like solar, I think so at the initial stage the viability gap funding has to come from the government, and we are very much sure that is going to come. So we are not going to achieve these figures, but so our target in 2030 also very doubtful, but still even we are able to achieve 50%, that's perfectly okay. And now the National Institute of Wind Energy, they are the nodal agency, and nodal ministry is MNRE. So they are identifying the potential site, and basically all monetary basically support that is going to come from this under the recommendation of nodal agency, the ministry will provide. Then we have given a very good repowering policy, because the old machines of wind turbines are below 500 or even 250 kilowatt. So those machines are built long back, so their capacity utilization factor is very low. Now the machines, that is, those machines are going to be replaced with a much modern and powerful machine. Now this is available in the onshore project, almost 2.5 megawatt, 3 megawatt size motor. So those are going to build it, and in fact, with this repowering policy, we can generate almost 30,000 megawatt by just simply by repowering the thing. Only thing that the grid infrastructure for or grid facility for those projects has to be built separately. Then we have a basically wind solar hybrid policy, because this policy was very much necessary. And yet one, if it is a 25% capacity of other source, then that will be considered as a wind solar. And this is basically, this will increase the, because wind generate at night and solar generate at basically daytime. So definitely ability will increase. That this is one thing. So capacity utilization factor is going to increase. And this thing, and this first project was very recently built under this policy, was 380 megawatt. And you see the kind of tariff we are getting. So this tariff is much below the tariff what we are getting.
Sir, your voice is not audible. Sir.
Hello.
Now it is audible.
Hmm. It has not come. Next slide. Okay. So this is offshore initiative already as per the policies taken. So first, basically, this is for wind measurement for bankable project. The LiDAR was installed by the. This is the basically facilitating offshore wind. This is the international is consortium. Basically, this consortium led by Global Wind Energy Council and also Indian NI. They are also part of that consortium. So they are facilitating for the by installing this LiDAR in Gujarat. And based on that, basically 2018, this 100 megawatt project was floated, which is under tendering stage at this moment. And then another 5 LiDAR is already planned to install to develop almost 7,500 megawatt project. And they have identified 16 potential site for demonstration project ranging from 150. What you can observe from here, that capacity utilization factor for basically in the Gujarat side is varying between 27 to 32, whereas in the Tamil Nadu, so basically Tamil Nadu side is much better in comparison to the Gujarat side. So investor is now basically inclined to develop first solar offshore project in the Tamil Nadu side. Although the first project, this is going to be coming to the Gujarat. Okay. These are the very various advantage, because you can put a very larger plant, and we the wind speed at the sea is much more than the onshore project. So definitely that will increase the capacity utilization factor. And it has a lower turbulence, because at the land-based project, lot of turbulence is there. So that is also creating a lot of fatigue in the wind turbine. So wind turbine will be much safer life or much longer life if you install in the basically offshore. And and the velocity is very consistent, so you can get a very higher capacity. Now the big machines are coming with a 60%, 60% if it is 15 megawatt, 20 megawatt capacity wind turbine. So that capacity utilization factor will be it is almost a thermal power plant. Now thermal power plant are operating at a 55, 56 basically PLN. So you can understand, and less visual impact, that is the issue of social. Then it is close to the load center, because now you can see our peaks issues are far away. But if you build in the zone, so they can supply to Chennai, Mumbai, and other places, and it can be built very time. But the cost of offshore project is almost 30% more than the port. And presently, the what we are finding from the various report is the cost is coming almost 7 to 9 rupees per kilowatt hour, and where in solar project is hardly 2 rupees 70 paisa to 3 rupees. So this is basically offshore, but with the capital subsidy, because solar was also, if you see the 10 years before, even government has given a tariff subsidy of 12 rupees. That kind of subsidy was given in the beginning stage, and now you see no subsidy, nothing, and still we are able to. So when the economy of scale will increase and we are going to build larger plant, so this will definitely going to reduce a lot and may achieve these figures very soon. Okay. So, and India is basically a solar hub because of the location, and we can, even if we go for a solar thermal, you need an area of 60 kilometer. You can 15,000 square meter. You can generate almost 3 lakh megawatt with the solar thermal, because solar thermal has a efficiency in the range of 30%. That has been particularly parabolic trap technology. So you can generate, although the solar thermal has not taken up in India because of its long gestation. So naturally, the investor is very, very interested to invest in a solar PV because its gestation period is very low, and so they are getting the return in very soon, within 6 months, 1 year. But once that is over, then definitely this will come, because this is also required for to meet our ultimate requirement. Okay. Next, so this is the solar map. So our current estimate is 7,40,000, 48,000 megawatt from the solar. Considering that wasteland available in India, 3% wasteland will be available for putting the solar PV solar plant. So this is the kind of, and we are also going for a floating solar also. Floating solar has some advantage. I'll show in the next slide. And now the largest solar. Okay. The largest solar plant is now, solar park is now in India, which is 2,250 megawatt capacity. This is the largest solar. Recently, the 600 megawatt floating solar also order was placed at a tariff of 3 rupees, because this price is little bit more than the, because of the mooring device. So you need, so that is the reason the cost. But this cost also going to be reduced very soon. So we have a different target already, but floating solar, we have a target was 10,000 megawatt, which we are going to miss very soon. But definitely we are going to achieve. Next. Okay. So this is the various component of floating solar. I think so. Or you go to the next slide. I need not to speak much on that. Okay, next slide. So what is there are various advantage of basically these are various components. Basically, there's a floater is there. Then there's the mooring system, basically to allow adjust the water level, and then PV system for electrical connection and underwater cable. Now, floating system developed by CL Terra, they are basically the French company. They have patented this one for a floater which can withstand a 210 kilometer per hour wind speed, even water level difference of 10 meter and 2 meter. This basically what we are basically preparing a detailed report when one of our project 14 megawatt basically floating solar project. So we have used this floating device for that project. So and it was basically that Nagarnar reservoir where the potential was almost 14 megawatt. Okay, next. So this is the basically floater which has been patented by this CL Terra, and this is the technology. So these where basically the solar panels are loaded, and this is the place where for working space, and this is additional floater. Okay, and this material is HDP material, not the any other material. So it will not it will sustain the environment of the water. Okay, next. So this is the, if you see the pictures of how the floaters are like this, where the panel will be built here. It is without panel. So here the next. This is the basically the, if you see the efficiency, because over the water, so there will be a temperature balance. So now you know that solar PV efficiency is if the temperature increases, it's down. So if it is over the basically water, this is blue. So you there's an increase in efficiency, then the land base, and this depending on the time, this efficiency will increase from 5 to 11%. Okay, next. So these are various advantage, and also it reduces the basically evaporation. Almost 70% what basically the water it reduce. So it is a basically wherever the industrial plant is coming, where a lot of water evaporation take place. So that is very important for us to put a floating solar on that, because those are very stagnant water. So this will be very useful to reduce the water consumption, and also it will basically slow down the algae formations in the here, and the efficiency part already I have talked this. Okay, okay, next. This is basically another PV is known, and this is concentrated photovoltaic system. Okay, this is the just a 3.2 kilowatt type. This was basically when I was discussing one of the supplier. He was the only supplier in India. We initially thought of putting this one in our basically Mekon building. Then after discussions, we did not take it up, because this is not suitable for this location. I'll tell in the next slide. Okay, next slide. Now, what is done basically here? Basically, some optical things taken, which is basically the concentrating the solar on the PV cell. Now, these PV cells are basically the multi-junction PV cell. Normally, other places two-junction mini cell we use. Now, with a multi-junction, it is a 40% cell efficiency is possible with a even basically with a three-junction cell. Because and if you increase the if you go for a multi-junction, this efficiency can reach to a level of almost 80%. So that is a theoretical efficiency, even 86% you can reach. But and the module with a 40% cell efficiency, the module efficiency of DC conversion is 30%, whereas in the normal crystalline solar PV, the efficiency is 15%. Now the monocrystalline, the efficiency is something 22%. Okay. So, but it was only in the DNI component, direct normal irradiation component of the solar. Solar has a two kind of radiation. One is direct, and other is the diffuse. So it does not work in diffuse. So whenever there's a cloudy and other time, it does not produce any power. So that was the reason. And wherever there is a DNI component more, so this is more suitable. So there's a discussion. This will be very much suitable for the area of Leh and other places where the DNI component is very high in comparison to other places. Okay. Next. So this is a triple junction cell. So basically it capture, you can see that wavelength. So it is a wide range of capturing. So if you increase the multi-junction, so more broader range of wavelength of light that will be captured. So you can generate. So that theoretical efficiency, what we are saying, that is you can reach up to a 80%, what I've said already. Next. Now, another thing, you can see the performance of this, because normally the solar crystalline mono or poly, they are basically degraded, the efficiency degraded a lot, and if temperature increases. But in the CPV, that it does not degrade. So this factor is almost 50% of the that temperature. It is almost 50% of that this factor. So this is one of the most advantage. Even it is work in a 40 degree temperature, it will not reduce much power. Its efficiency will be almost same as is 20 degree, which is the normal conditions. Okay, next. So this is you can see that how the powers output at different time. Now CPP, because it is working under DNI component, so it is almost flat. So it generates, so it is almost flat. Now, if silicon that is mono or poly, then if it is a tracking with a tracking, then it will can be flat. But thin film, it is basically this kind of, so a variation in the power output. So this is basically very important. But this earlier it was used for the space application, the other thing. Now they are thinking to apply in basically in the land base. Let us see what happened. Okay, next. I'll just talk about something about the ocean technology. This is also one area which I have worked in some form. Basically, I was involved in the tidal energy project for both the places, although these are built up, but the document preparation, DPR preparation, that time I was involved. And at the initial stage, there was a project we got from some report was prepared for the wave energy. That time we are also involved. So, okay, next slide. Now, three kind of basically the tidal energy is basically work on the tides that we know it is because of the attraction between sun, moon, and the earth, and that is the reason. So, we tides got. So, these tides are basically specific located. It is not everywhere because of the resonance happens in the estuary and other places. So, in basically what we have seen, like in the Koch, Gulf of Combat and Koch area, where the tides are almost 7 meter, 9 meter high. So those places are very good for a tidal project. So we have a barrage. Normally, barrage scheme. We create a barrage on the sea itself or on the estuary itself. Then when water basically enter when there's a high tides, and then when the sea is receding, that time we use a bulb turbine. This is a very low basically head turbine used for the power generation. Similarly, tidal current also being used for power generation, and then wave energy. It is because of the interaction of the wind and the sea. So there's a lot of waves formed. So a lot of we both you can use the kinetic energy as well as potential energy for utilizing generating the power. And there's a OTEC also because there's a temperature difference between the sea top and the bottom in the tropical country. In our it is almost 22 degree, 23 degree. So utilizing that thing, you can generate a power, but it has a very low efficiency, hardly 1%, 2%, and you have to use the fluid like ammonia or other thing. One project was Indian government was taken long back, so that was barge mounted project, 1 megawatt project. But what happened? That project after almost investing something 50, 60 crores on the project was abandoned because it was not feasible. It was not cost economical. So this was the okay. Next. So these are the basically you can say that our basically ocean energy map, where you can see that our tidal potential and also the wave potential. Wave is basically defined is basically this 13.93 kilometer per meter square of the height of the wave. So it is maximum is basically in this zone, Kerala and Tamil Nadu, where it goes up to 20. If you go further down in the New Zealand, this is much, it is 50-50. So these are very popular wave energy project on those country. And in West Bengal, you have a 900 megawatt tidal capacity. Okay, next slide. So basically, this concept, just I'm telling tidal basin concept. This is a very popular concept where I have already told that tides were basically dam basin was created, and which allow the water to enter or leave the tide basin during flood tide or high tide or during ebb tide or low tide. So this is the basic concept for generating power from a tidal basin, and it has a various scheme. Single basin, single effect scheme means I will explain through a figure. One way tide working scheme, either ebb or flood type, that time will generate power. Then single basin, double basin, both time will generate power. When the water is entering the basin or water is going out of the basin, both time will generate power. And the double basin single effect scheme, this is basically we create two basin. So from a higher basin to lower basin, from higher basin the water enter, and from the lower basin the water again goes to the sea. So this is the concept, basically the tidal basin concept. Just I am figure through figure, you will be able to understand better. Okay, next slide. This is the things you just see. This is the basically how the sea loop. Now, this type of wave basically almost in India we have seen 702 waves in a year that is happening, and this amplitude is varying depending on the moon sun positions definitely. Now, how it is works you see, because when tides are basically when the high tide, then there is a dam and there is a sluice gate. We open the sluice gate, water entering the basin, and this is the, and once it reaches this level, then we start pumping. Same generator basically is acting as a pump, like in the hydro turbine we have seen. So it is pumping, and we can raise the level, further level in the basin, and after certain time pumping, then when we are getting the sufficient head. So now this is the head difference, if it is with pumping or it is without pumping. So basically this is the head difference. So we start generating power, and when when the head is reduced, so this is the basically, then we just generating power here, and then again filling, and that way it is repeating. And in case of a basically this is a single effect. Either basically we are generating power when basically when sea level is receding, and here you see we maintain the sea level here, and when water is entering, that time we are also generating power, and then there is a normal filling, because this is the head I am getting, and then again there is a pumping and we are level increasing, and then again we are generating. So both flood type and ebb type, so both way double effect scheme we are generating power. So this is one thing. And next is basically, you go to the next. This is a basically two basin simple concept. This is the low basin and this is the high basin, and the we are generating power. The water enter the high basin, and it goes to the low basin through a turbine, and from the low basin it is going to the sea. So this is the way this power is generated. Okay, next. So this is the comparison which was made earlier. So if you see, if we take the single basin and single effect scheme, our relative operating cost, if it is 100 and relative energy 100, so most suitable is basically, you see that single basin double effect scheme with pumping, which is giving 42% more energy with a cost increase of only 14%. Now this is the scheme, but double basin scheme basically it increases because of the dam size, other thing, the cost is increasing, and but energy is not getting. But yes, you'll see the availability of energy will increase for a greater period. So this with this scheme, basically one plant is operating 240 megawatt for a long time in France. Okay, next. Okay, next. This was the project for which the DPR was prepared. Ultimately, project was not taken. This is the basically Durgadwani. This is a Vidya river, and this is a Gosaba, where basically biomass plants are working to give the power based on energy plantation. And this is the creek, basically Durgadwani Creek, and this is the river. This is meeting here, this river. So this is a land portion. So instead of putting the power plant, we have created a basically powerhouse here, and this was basically a dam was created, and this side the dam was created. Now, when the water level increase, then water will enter to this basin. But here, basically, we cannot use the basically pumping, because what we have observed that water level in the basically this creek is even more than the level of the Gosaba land. So if there's a water increase some level, then it will be flooded this level. So that is the problem. So pumping was ruled out here. So whatever water is coming, so it is a basically single basin, single effect scheme. So that was proposed for this scheme. Now next. Now you can see that with a single basin ebb generation scheme. So this was the kind of generation. Now it was almost generating, but our availability was 37%. So one of the issue was there was no grid existing in Gosaba. It was almost 80 kilometers from that place. So, and when you need the power, you will not get this power. So it was decided that when the grid facilities will be there, because it is then that time this plan should come. And then we think about, yeah, we should go for a two dam scheme. So that is the next slide. Okay. Okay, you can see that two dam concept, where the higher dam and lower dam, our energy reduced, but our availability is increased 70, almost 74%. but our turbine capacity reduced. So this was the problem. So the project was completely non-viable. That is, with this kind of energy generation, it was not possible. So project was abandoned. But I am very much sure, if not now, that at least with that concept, the project may come in Durgapur. Okay, next. So it has a various advantage and very predictable power generation. It is very much known, and most important thing, yeah, it has a very long global experience. And the plant is operating 240 megawatt plant. It is a 24 number 10 megawatt bulb turbine is being used, where the tides are varying from 8.5 meter to 13.5 meter. That is the kind of tides is available there. So this is the plant operating from 1966 and giving this much power every year till today. And they have used the basically because it is working under sea, so they have used a cathodic protection for the protection. So it was inspected even after a 30 year. The equipments are exactly same. It has not degraded anything. Okay, next. This next. This is simple. Basically, it is a wind and basically the sea water interaction. So basically, this wave is formed. So we can use both the kinetic energy as well as the potential energy for generation of power. Okay, next. So there are various technologies available with this. This basically oscillating water column, where basically this water column will act as a piston that I'll show in one. Then oscillating bodies, basically where floater is going, so there is a pump. You can operate a reciprocating kind of pump. Even a motor electrical generator, which is linear electrical generator basically. When the float is moved, so your magnet will move up and down, and that will create electricity. So that will be dispatched to the basically the onshore places. So this is the average in India, but in Kerala and Tamil Nadu, our wave potential is very high. So these are the locations where this project should come. Okay. Okay, next. So this is the basically you can say now this is the oscillating type. You see, this water column is acting as a basically floating device, and when is as a piston. So air is going and air is out. Now this turbine, present turbine, it is a well turbine. So your blades are basically symmetrical. So whether the air is going from bottom or what is or air is coming from top, it is basically rotating in the same direction because of symmetrical nature of the blade. So that is the thing. And this plant, this kind of plant is operating all over the many places. And it is first project was built in 2000 in UK, where it is operating till date. So, okay, this is okay. This next, and you can see this is a horizontal turbine also. The same thing you can put. So this is wave. This is acting now. Next. So either this is basically oscillating body converter. So these are the converter basically where basically floater is giving. So and the motor or any other thing or any pump that pump water to the to the basically onshore height, and then they generate power from a turbine. There are various kind of use here, so I can just show some figure. You can say this is not the OCW. There are different kind. A hydraulic generator with linear hydraulic actuator, the linear electric generator, piston pump you can use. Even with this, basically you can generate a power. Okay, next. These are the various things where this is up and down. With this, basically, when the wave is up, then it is coming. So they operate a piston pump, and that pump, that fluid, basically there's an accumulator, push into accumulator. Then from the accumulator, the water that is fluid is coming to a basically hydraulic pump, and it's generating power, and then again release. So those kind of systems will build up. Here also it is basically actually this is also oscillating type. So these are basically, that is a principle. It's operate just like a piston use pump, and indirectly it generate a power from this. Okay. Next. These also, I have told that a 500 kilowatt plant based on well turbine, what I have already told, it is operating since 2000. And these are very predictable, and almost efficiency is 70-80%. So once you build up this project, so you can basically coastal area, you can power supply to the people with this system. Okay. Next. This is biomass power. We have a lot of agriculture waste. So our potential is more than 22,000 megawatt. We have already basically from bagasse cogeneration and wood, we have generated almost 10,000 megawatt. And recently some policy, next, you go to the next slide. Now some policy has come where this co-firing of basically this biomass with the existing power plant. So that is a policy. So minimum it has been 5% has to be co-fired, and it has to be increased to a 10%. But we cannot increase further. So a lot of research is going on because of the presence of high silica and the alkaline. So this is the restriction, and so because these plants are not designing for a high silica, sorry, uh, high silica plant. So that is we have restricted. But with this, basically the lot of problem what is happening in the basically Punjab and the Haryana and the UP. So this can be solved. Even last year, basically the NTPC almost 70,000 metric ton of biomass is used in their plant. So this is the kind of basically under this policy, and definitely that is also reducing the basically carbon dioxide emission, net carbon dioxide emission from the plant, because biomass is considered whatever they are absorbing and they are generating, it is same thing. Okay, next. We have a geothermal potential also 10,600 megawatt. These are the locations. Now, first project is coming in the Ladakh area, in the Puga, basically, where first 500 meter drilling is doing by ONGC. But this can support almost 250 megawatt plant with a much deeper drilling in the second, third stage. This kind of plant required almost 2,000, more than 2,000 meter of drilling. So that is required for an expert. So, but this is the project government of India has decided to build up, and which can support the lay area with this power. Okay, next. Now, this is the very recent policy has come on green hydrogen. Now, if hydrogen will be green, if it is produced through electrolysis process using only the renewable energy. Renewable energy means it can biomass, solar, wind, and hydel also. So this is so then it will be considered. So some rebate is giving. So this plant can be built any location. And they can draw even a co-located plant. It can be remotely located plant by other developer or third party purchase or purchase from exchange. Anything can be done. So still it will be considered as a green hydrogen. And the all interstate transmission charges has been waived off if it is commissioned by 2025. So this is the policy, and the government of India is planning. The first we are planning to blend 2% with the CNG or PNG, and which is gradually increased to 5%. And next phase also this will be used in a hydrogen driven car, because that is fuel cell based hydrogen driven car. So that is, and for the household PNG, that will be supplied to the cooking, basically for the cooking purpose. But some things after burner, they are doing experiment whether we can increase this thing more than 5%. That is going on. If it is possible, then further increase will be done. This hydrogen also can be used to generate electricity through fuel cell, and because of the variable natures of the basically wind and solar, So we can put power on a continuous basis, and we can contribute to the grid stability. So that is also on-site generation, power generation, and putting into the grid to make the grid stable. And this oxygen produced from the basically hydrogen generations, that can be used basically for industrial purpose as well as medical purpose, because this is very pure. Okay, next slide. And but at this moment the capital cost and generation costs are very high, so it needs to be brought down at least 1.5 per kg of green hydrogen to uh, match with the other kind of energy sources. The first project was built up by Indian Oil Limited with a green hydrogen of 99.99 basically purity of 10 kg per day, with the support of 500 megawatt solar plant, kilowatt solar plant, and it is to be scaled up of 30 kg. Okay, next. So this is you can see that some optimization cost is required. So these are the basically now the cost is varying between this range. Now to achieve a 1 USD kg, what we need, and these are the different power costs. Now power cost has already reduced to a level of 2.5, and our annual running hours, if it is a 700. So if you give this kind of annual hours, so that means it has to mix up with other kind of sources. Then you can ensure the supply for 700 hours. So if you do this thing, then in that case, and also the capital cost, if reduced to 100 USD, then we can achieve this figure. So that is the target, and it is expected. The Indian government is taking a lot of initiative. You can see that many big investors, they are investing in the renewable green hydrogen project. So it is expected that this cost will achieve in a few years from now. Okay. Uh, One other important thing is the energy storage requirement and its development status, because now the renewable energy is no longer is controllable. That is because totally depends on the seasonal. So to support this one, basically, so a government has already brought a policy, and now this is basically battery energy system, basically lithium ion battery, basically, or it is a pump storage plant. So we have a very huge capacity of pump storage plant in India, 1,20,000. This is the assessment, and we need something 41,000 megawatt by 2030. Now we have installed something this kind of megawatt. So 17 project build up, but this project takes long time to build. That is a one issue. Now we have a doubt that how we'll meet the this requirement by pump storage. So we have to depend on the battery storage. So government India already has planned, already issued a EY for 100,000 megawatt hour battery storage system, and two large capacity 13,000 gigawatt hour, 13 gigawatt hour and 14 gigawatt hour. Basically grid scale battery energy storage system they planned in Ladakh. Whenever required, that will be fed into the grid based on the requirement to give the grid stability. And also, recently, the Solar Energy Corporation of India, they have invited the bids of 4,000 megawatt hour grid scale battery energy system to various regional load dispatch centers. So, a lot of activity is happening, and this is required. And we need this much of power to achieve what we have thought about in by 2030. Okay, next. Okay. Now, what are the key challenges faced by this sector? We have a different policy, but till date, there is no comprehensive regulatory policy is available, which is very much required based on our experience in the various for the development in this sector. Now, RPO applications is not made by various DISCOM. That is also we have seen. So need strict compliance. That is very much it. So now government India has already opened a basically some sale which will be directly monitor whether the state government is meeting this requirement. So that is happening, and RPO obligation is now only for solar. So it needs for others renewable sources like offshore wind. They are also demanding tidal wave if you want to develop. So this RPO obligation has to given, because this has to be bundled with other project. Then it can basically further basically we can develop. Then we have a institutional obstacle. There are a lot of times in policy implementation, project clearance due to poor inter-institutional coordination, decrease sometimes the interest of the investor. Then financial obstacle is also there. Budgetary allocation sometimes is less and not released in time. This is one thing. High initial cost of acquisition. This is also another issue for particularly the new and which are in the early stage of development, like the offshore wind, tidal, and wave energy project. Okay, so they need say capital subsidy as well as the tariff subsidy. Either of these things, which was given in the earlier solar project, and then our uncertainty of related to the assessment of resources and lack of technology awareness. So that is also bottleneck for the investor to invest. Okay, next. And then other financial obstacle is our bank basically who is giving the loan. They don't have much understanding about this sector, so they hesitate in financing this project. And then most important is the poor financial conditions of the power distribution company. This is one of the main reasons, resulting in a very long and unsustainable payment cycle. So this is a big issue. Although during 24 into 7 time, it was addressed and a lot of support was given, but still you find that this power distribution company are not is operating in a loss. So this is a one issue. So payment cycle is very low. So that is also another issue why people are not interested. Biomass supply market was completely unorganized. So there was a lot of fluctuation in the price earlier. Hope that after this policy, this price will be stable is one thing, because what we observe that even when they are going to throw, then that will be no cost. But when somebody is going to purchase, they are demanding very high cost. So that was happen. I've seen in some of the project when we are doing. So this is also the non-availability of land for a large project. So that is also going to be a bottleneck. Then some technology obstacle, because government there's a very not many well-established research and development center. Very few is there. So we need adequate institution and laboratory for development of this sector, for particularly the R&D activity, quality certification, validation. Although some R&D activity through imprint, some project was allotted. I know although 5-6 projects are undergoing, but it needs a lot of investment, and lot of institute has to now work on this area. So this is very much necessary for the future development of this sector. Okay, and we are still we are dependent of technology equipment on the foreign supplier in many cases. Okay, next. And then we have a awareness problems that we have seen. Uh, yes, we have a non-availability of sufficient trained skilled manpower for renewable energy sector. Then is a lot of lack of awareness among the general people. Even I've seen even the urban people also does not have much knowledge about this sector. So this is also very important, because sometimes you have to purchase power in a little bit higher cost to save our environment. So that is a very much need. But major problem, unless the per capita is increased, so rural people is not going to sustain those kind of costs. And lack of awareness of the technology also sometimes a significant obstacle for the development of it. We have a lot of environmental obstacle is there, because wind farm project, offshore wind farm project, is it can affect the basically oil and gas extraction, navigation, and fishing also. Marine wildlife also likely to be affected. Onshore wind turbine influence wildlife. It has been observed that bird and bats, because of the direct collisions, and also because of the basically noise also. It has been observed that it reduced survival and reproduction capability of the habitat. It has been seen. And the pollination, even because of the reduction affect the pollination, So sometimes it has been seen that agriculture yield has reduced. So these are the various studies. Even in fact, in European countries, sometimes they thought of the onshore wind turbine rather than going for an offshore wind turbine. So that was also another thing. And these habitats are very important for our right because this is they eat the destructive insect, birds and bats, which are enormous, give enormous benefit to the country agriculture sector. So this is very important. Noise and visual impact sometimes create a issue with the social people, public health hazard. With the manufacturing now, the large scale PVCL manufacturing is going to happen because it contains some toxic substance. So strict quality control and other thing, which is not a lot of public health hazard may happen because of this toxic substance. And then disposal of SPB will be a big issue unless after decommissioning. So if it is not basically unless it is recycled and reused. And other obstacle is basically development of adequate storage capacity for renewable and bottling, because battery-based system is very expensive at this moment, and whereas the pump storage base is basically systems are have a large gestation period and also have some social issue because of dam, so it can submerge in other places. Okay, I think so. Thank you for present hearing.
Thank you, Prabodh, for giving us overall idea about the renewable energy planning and the future of renewable energy initiatives in India. So we can go for some quick questions from the audience. Vidyut, how to organize that? Will it be directly asked or?
It can be directly asked.
Yes, sir, that's not a problem. So, thus, can you please unmute the audience so that they can ask directly?
Yes, I have unmuted all.
Bhattacharya is raising his hand.
Sir,
Vidyut,
Yes,
Vidyut,
sir.
if somebody is not questioning, I have got few points.
No,
Yes, sir.
Achyuta, Professor Bhattacharya has
Please,
already.
I should go for question.
I'm
Yeah,
mute.
yeah. Where is Bhattacharya?
Yeah, he is there. Professor Bhattacharya has already raised his hands and he has been just unmuted. He was not able to ask question. Probably
Please.
now. Achyuta, you please ask after Professor Bhattacharya.
That will be fine. Thank you. Thank you.
Dr. Bhattacharya, can you unmute yourself? You're not audible.
sir, please unmute yourself.
Can you hear me? No.
Yes, now.
Now it is okay. Now it is okay.
Okay. No, I won't take time.
Hmm.
I personally feel that the cleanest energy and the most efficient energy, which we never talk about, is the energy which is in form of saving power loss and saving wasteful consumption. Now, if we have 2 lakh megawatt generation
Mhm.
out of installed 4 lakh, whatever we generate, let's say 2 lakhs, 2,50,000 megawatt. You see, theft is not a loss. Theft is not giving money. Otherwise, it's a useful consumption for the people who is stealing. I'm talking of
Yeah,
technological
I understand. I
saving,
understand.
where India stands vis-a-vis other countries which basically in form of transmission, distribution,
Yes, yes, yes.
substation,
I
various
understand.
things.
I can.
think
No, no, no. Yes, yes. No, no. That part. Yes, yes.
saving.
Because
So 5%
because
of 2 lakh megawatt is 10,000 megawatt, and that's cleanest power. It does not require any fuel, and that is not having any loss, further loss. That's absolutely a cream. And second is, when at this age we see the cities and other things, what power we waste. You see, economic growth will need more power, no doubt about it. But when we look at a city, when we look at our consumption, when we look at our personal consumption, I still believe that without hurting economy, somewhere another 10,000 megawatt we waste. Particularly, this is in the urban societies and urban lives. Even 5% of what we, you see, not putting off the lights. I see in my own housing complex that lights are not put off in time, the common area lights and other things. I think that's also a large amount of energy. Now, the second
no,
one, okay, it may not be very interesting for CSC, but it will be very good for the nation. So I
sir,
personally believe, along with generation,
no, no, sir, sir.
just I'm finishing in 1 minute.
Hmm.
Along with generation of renewable things and fossil fuel, we should focus on saving of wastage and power loss, technological savings of power loss. Thank you.
Yes, yes. I am giving some of my experience on this because when I was working on the planning document for the states, this was definitely, I have talked about the generation side. Now, the demand side also is equally important, demand side management and other things. So, even by the lot of initiative has been taken by the energy efficiency and other thing, which is even lighting, changing the basically from CFL to LED. So this is going to save a lot of energy. Even in fact, that time there's the assessment of the 30,000 megawatt we can save through energy. Hello, is it hearable?
Yes, yes.
Yes.
So almost 25,000 to 30,000 energy can be megawatt of power can be saved only by just by demand side management. So this is one thing. Now there's other thing. The losses basically, now technical loss is technical loss. Now commercial loss component, there are many states where we are giving a basically free power. This is a big issue. Free power to many people. I think so. The free power may be required. That is a debatable or not required. That's debatable. But I think so. Instead of giving, once you give a free power, so once somebody get a free power, say use it without any control because it is free. We have seen in a village in something in Haryana where they have all the gadget, all the electrical appliance, even big mixie, but they pay only for 50 kilowatt because when discussing on the discount, this is the kind of thing. Now every loaded, but so 50 kilowatts, so, but basically energy they are consuming, they are a lot of energy consuming at the same time. Uh, so to control all those things, basically the direct subsidy is more important than giving any free power. So all power should be metered. This is very, very important. All power should be metered. And then to whom you want to give subsidy, so that you give. Otherwise, something happens. Suppose there was a study in a long back in one of the state. I do not want to name that state. But these things happen because the power was going to the farmer, and the farmer has a restriction of the size of the motor what they can use. Uh, and finally, it was observed that they are basically not consuming the kind of energy which was shown against them. It was consuming some other places because of the some industrial people, other thing. But because and it was simply shipped on to them because that was unmetered. So these are the things. There are many complications. So it was decided that let us give a direct subsidy to the people only. This is also, so commercial losses is very, even we have seen some of the state, these losses are almost 50%, 40%, but it cannot be it cannot be a technical loss. Now we are improving our distribution system with a 11 kV, even lot of armored cable is going, and even going to the distribution end, we are putting a transformer. So a lot of things is going on. In fact, after 24 into 7 study, I think so major investment has not taken place in the generation sector, particularly in the coal and other things. In fact, that is reduced by 50,000 megawatt. So major investment was taken place in the transmission and distribution system. So that was the basic things. They identified a zone. In fact, one of the state government, they told also, because the area where we are getting the revenue, because they're metered, so they are giving a power. Where there are a lot of theft, they are giving a less power to those areas, unless it is all metered and other things. So this is the consumption side, basically is very important. Is very, very important that how to optimize our consumption, how to reduce our theft. This is perfectly is very important. But I think so a lot of activity is going on this sector, and that is also going to be achieved by Government of India, I think so in future. But yes, there should be a political will to do that. Because I have seen in some state even that distribution company people, they cannot enter the village. That things also happen. So that you try to understand. Okay.
So, Achyuta, please go ahead with your question.
Thank you. See, I have got 1 point, 2 points only. I will suggest now what Professor Gautam Biswas has told about Prabodh Maji. We are all afraid. What a brilliant brain. It is accepted. Thank you very much for introducing it like that. But I will say 2 points only. One, each man who has a house is a potential generator of power. And that is the easiest way is through silicon PV. Throughout the world, wherever you go, you will find people are using their rooftops generation of power.
Yes,
But
yes.
unfortunately, in my country, in West Bengal, I am talking about West Bengal, some flimsy cases come and net connection is just stopped. 31st, today is the last day of requesting the connection to electricity board, and till now they are not giving net connection. Now, unless it is net connection, a man generates power in the day. He is not using that power in the day. Workshops can use that power. He will use power in the night. So, unless there is a net connection, individual rooftop connection with battery is a messy thing. It cannot be done. So, kindly see that net connection, grid connection is allowed in this country. My
Sir,
state
no.
first. Sir, please, this is not done in West Bengal. I
No,
don't
sir.
know what.
I don't know. It has happened, sir. Even in Jharkhand also it has happened. Net metering is now, because we have installed the 140 kilowatt in our office rooftop, and now we have connected with the grid also. Sir,
Sir, I am
this is,
talking about West Bengal. I am talking about West Bengal. You may be in, I don't know, some other state in Mekong, in Jharkhand. Sir, this is 1 point. But anyway, I enjoyed your lecture. It's so much of knowledge is there. But one thing, I've got a small criticism for you, sir.
yes.
That is, while you are showing, it's a slide projection is a media where human brain reacts with photographs, with graphs and all that. But sir, I am sorry, Dr. Maji, that your slides, 80% of them were of 40 line, 30 line slides, which are not much appreciated by human brain. But I must say, thank you very much for a beautiful picture, a wholesome picture. Your knowledge is so much. It's enjoyable. Thank you.
Thank you, Achyuta. Prabodh, you know what Achyuta said,
Yes.
probably, you know, visual effect is very important. You could have asked your company to, provide you with some visuals with your, topic, or with your sort of commensurate with your whatever you want.
And the cables can be replaced with graphs. And who remembers these cable values? Nobody. It's a graph, comparative graph. Those hits your brain. Anyway, thank you very much.
Thank you, Achyuta. Thank you, Professor Bhattacharya. Is there any other question? Not one or two, maybe, there may be multiple questions. So, are there questions?
Batteries are impossible. This lithium, people are fighting all over the world.
I am allowed one question, sir.
Please.
Professor Ghosh?
Through the fear, yes.
Yeah.
Yes, Dr. Maji, how do you see the prospect of hydrogen infrastructure in this country, development of hydrogen infrastructure?
I think so. Even if you see the recent basically announcement by our oil and gas ministry at Davos, he is very clear that hydrogen generations, that will be India will be a hub. Even India is planning to basically export. So this is the area definitely. Even all the our institutes should work on this area, and there are a lot of R&D has to be done in this area also. And government is taking it very aggressively, particularly what I'm finding. And you might have heard that big industries like Reliance Industries and other people, they are planning to invest in a huge money on this sector.
I have one addition, sir. All large hydroelectric projects are self-defeating. They should not be done. Large hydroelectric projects should not be done. They are dangerous. They create devastation in the country. People are uprooted. Or you do 5 megawatt
Compressed natural gas.
small hydroelectric projects. Large hydroelectric projects are not viable in this country.
No,
Anyway,
yes. So that is really non-viable at this stage. But sir, if you see even 10 years before, I have seen where the tariff from the solar plant, it was coming something 16 rupees per kilowatt hour. The capital cost was very high. We never expected that it will reduce such a level. So when economy of scale, it will reduce the price. If everybody is going to invest a huge size of plant, so definitely this is going to reduce. Definitely is going to reduce. Today we may not think that. That is the reason I'm telling you what kind of basically the capital cost has to be reduced. So now it is almost 800 to basically $1,400 per USD.
I can add new materials are coming in place of silicon.
Yes. That is
Still reduce the cost, and
uh,
that substance abuse that will be again not present. That silicon problem with human body. They are coming with new materials.
even the sodium ion battery is also coming. That is also another area, and that will be much.
Solid batteries.
With the development of EVs, battery technology will be coming up very fast. That is for sure, because you have to compete with the EV development. As more and more EVs will be coming, you have to develop battery also, because that's going to be the primary storage for vehicles.
Yes.
But for renewables, do you think for renewables, finding the right mix, location-wise or rather state-wise, is a primary concern? Because one uniform policy is not going to help the country. If you have a national policy as to what should be the right mix, that's not going to play well with the state.
No, it is not that, because if you see that majority of the wind basically potential that you have seen, so you cannot put any other places.
Regional bias.
So this is the reason. So wherever is the location, suitable location, you can put solar. You can put everywhere. Definitely, large scale solar power plant is coming in Rajasthan, because that is the most ideal places. Even the Leh is also equally ideal place for putting solar plant.
So naturally,
we cannot tell, but ultimately there should be a very robust national grid through that the power has to go through everywhere. And land, naturally, even land acquisitions is a issue even in our state also, that you know very well. So
That's why
putting a
I mean, mix, a planned renewable energy mix is a necessity, I think.
no, state-wise plan even for the rooftop was there. Now, out of 1 lakh megawatt, the 40,000 is supposed to come from a rooftop, but that is not progressing. That is the things. Whatever coming, it is coming from land base. Sir has already told that rooftop is very much necessary, but for that you have to create a conducive policy. That is the responsibility of the state, basically state. So and state renewable energy authority, they have to give a net metering and other things. In fact, some of the country, they not only put up basically solar, even they are putting a micro turbine of 5 kilowatt, 10 kilowatt, and even for the fuel cell uh, from their biogas or biogas plant, and they are generating power. This will save lot of basically you can utilize your transmission or distribution structure very optimally. You need not to basically, because you are consuming power, so there is there will be a peak requirement will not be there, so you need not to basically increase your investment in the distribution also. So these are the things. Even one of the project finally we could not work, we could not get. Initial stage I was involved. That is from Saudi Arabia. They were interested in the entire country. These kind of things. They want to put micro turbine or solar for every houses and it feed into the distribution network. This is very necessary. This is very necessary. But it is not happening here. That is the thing.
Shudha, one thing I will tell you, we should not put all idle projects in same bracket, same box. If you really, because I have seen Quebec, I have seen Aswan, this Niles, that one, and I have seen Chukka, our own Chukka project. Well, you see, it is the selection of the project which is important. Otherwise, I think these Niles or Quebec or Chukka has done no harm in the last 30 years or 40 years or 50 years to the country or to the surrounding or to anybody. So it's really what type of idle projects, what type of decision making, those are important. All idle projects are not bad.
No. I'll beg to differ in a way that some of the countries you are talking, sir, they are less populated. But India today, 139 crores of people.
Yes,
We
yes.
are densely populated. So our ponding
We
creates.
should not select.
That's it. That's
So
it.
I'm agreeing to
Choice.
that
Yeah,
selection
you said
the
that.
criteria.
Yes. To suit the
There can
society,
be
to suit
some
the. Yes.
say, I have a house in Himachal Pradesh, in uh, Palampur. I
Uttarakhand.
have seen their power plants. I don't think it has done great harm to them. So it depends at the end of the day what you have selected.
The
To take
Chipko,
responsible
Chipko
selections.
movement. That's in Himachal Pradesh. Chipko.
Movements you keep in India.
Probably,
If you want to put up a plant, environmentalists will come out of grave and become active.
Don't have to shout them down. Please don't.
probably
We
Achyuta and
made national aluminium. We made national aluminium.
Yes.
There was no agitation. There was no agitation.
Professor Bishar has something to
Somebody else
admonish
wanted to
us.
make another aluminium
Professor
plant.
Bishar is admonishing you and me.
No. I'm saying that Achyuta and Professor Bhattacharya, both are, right, and both are probably, trying to say the same thing in a slightly different language. See, today, obviously, building large dams and huge
Not viable.
high idle plants are definitely dangerous. But even today, if you look at Professor Bhattacharya was mentioning about Quebec. Now, even today, quite a few areas of Canada and United States, mostly the border areas of Canada, United States, and through which, basically rivers are all coming towards several lakes. They have planted a large number of bulb turbines. These are all turbines with very low head, and these are river turbines. And capacity ranges from 5 to 10 megawatt. And I know personally one of the professors in University of Iowa, Larry Weber, and also one Indian. He is no more in profession, Virendra Patel. He is also University of Iowa, Hydraulic Research Institute. They have almost done a miracle by proper designing, site selection, and all such things for bulb turbines. Now, in bulb turbine, I think we can really excel because our hydro machines division of BHL, they have superb expertise in bulb turbine. See, I mean, don't really, what should I say, identify me with any political party, but I would say that any political party after 1990 did injustice to BHL, because BHL is an organization which grew, fantastically in all its areas. Whether you consider steam turbine, hydro turbine, gas turbine, including helicopter, wherever they have, and fluid bed boiler.
Fantastic
Now,
company.
Yes.
fantastic company. Now,
Fantastic company.
our
Mr. বিশ্বাস, I like to mention one point. Canada has got 7 persons per square kilometer. We have got 7,000.
No, Achyuta, I have no argument in that. I am only saying,
Yes, you are correct. I was joking. I was joking. You are correct. What you are saying is correct.
if you utilize rivers only and turbines of that capacity, 5 to 10 megawatt range, fast flowing rivers, especially Himachal and north of Uttar Pradesh, north of Bihar and those
Some
areas.
hilly area where there
Yeah.
is some head.
So, I mean, and this electrification will not cause any damage to our population, to anything. There is no risk. And as I was mentioning, that BHL has developed real expertise. See, we are somehow government is, curbing BHL activities, reducing their, sort of several units into business units and all such things. But, we in energy sector, BHL really made a dent. And they
Resource wise, they are quite rich.
Contribution is unparalleled. Contribution is
unparalleled. Unparalleled.
Unparalleled setup,
Living our
unparalleled
life,
infrastructure.
living our life, we can always say this should not be done. But if you really see NTPC,
Exactly.
Power Grid, BHL, if these three were not there, I think selling of
Exactly.
hurricanes and lanterns would have been much bigger today.
So, BHL, the way it was growing, I know quite a few cases when I was working closely with them. They have defeated GE in international tender in Cyprus. They have defeated Mitsubishi in international tendering process in Greece. So they won quite a few international projects, and they could have grown even bigger, like GE or like Siemens. They could have dominated energy scenario throughout the world. Unfortunately, again, I'm not. I do not want to support any political party. Political parties that came into power till I would say mid 80s or so, they supported BHL. BHL was created by national initiative. But
Dr. Bishash, when I was in NALCO commercial head, I have dealt with BHL. There can't be, what you are saying need not be re-emphasized. There can't be a better public sector company than BHEL. I will tell you, because we had a 760 megawatt power plant. Now it is 1200 megawatt in NALCO. It's BHEL. Everything.
So there seems to be a couple of questions from our students. So if the chair permits and can take them.
Please, that should
But
be.
unfortunately, Professor Bhattacharya, somehow BHEL activities are being carved. The company which could have been, GE of the India, they are now restricted only within India. That too, only to some government company, a government by power selling companies. It is very unfortunate. Anyway, so maybe we can open to our.
But it's true, sir. BHEL infrastructure is unparalleled. I have visited their Hyderabad sector.
Professor
and also
Ghosh,
their Haridwar plant.
it is not only infrastructure, expertise.
Expertise also.
You look at BHEL engineers, you look at their expertise, you look at their performance.
Even in terms of technology absorption.
See,
About old days.
now companies like Alstom,
Sir, the
companies
student's
like
question, sir. Sir, the student's question.
Yes. So let us take up students' questions.
Yes, 2 questions are there from the students. So if the chair may permit.
No, surely. I mean, many, not only 2. Anybody wants to ask.
They have put the question in the chat box.
Chat box. Okay. So why are they not coming forward?
Yes, students, if you are available, you might speak out.
Hello, am I audible?
Yes.
Yes, I'm Shushma and I'm from 4th year of Mechanical Engineering Department. So my question was what can be the possible alternate source of energy for especially the middle part of India, which has no surrounding water feedstock, where we can't have the possible development of hydraulic energy, and also no immediate infrastructure to develop even solar energy. Then how can we substitute coal or LPG in those areas in the coming decades, where everyone is talking about renewable source of energy?
Those area you can go for some kind of energy plantation and then biomass power, because biomass powers also support nowadays even full producer gas type engines are available. Earlier there was a basically oil and producer gas, but now with producer gas the gas engines are also available. So
Grid
those
power.
those
Why not
remote.
grid power?
Hello.
Why we have to produce power everywhere of consumption?
No,
The
not
grid is
everywhere.
supposed to
Dr.
predict.
Maji, a national grid, good grid, electrical grid, and solar power. That's
Solar
the
power.
ideal solution.
See,
A national grid and solar power.
Shushman, why are you ignoring solar power? What is your argument for not going for solar power?
No, solar
Like,
power.
I'm talking about the underdeveloped parts where we cannot have the proper infrastructure of implanting solar plants on every rooftop. So
Why
what can be
not?
the possible?
Why not? Big towers can come there. Which part of India you are talking about? You tell me anywhere in central India. You name a place in central India or central.
He's trying to identify the region where not much of water
If
resource
I am
available.
permitted,
Which is that area?
No infrastructure is required for solar power. You
Yeah.
just throw the panel on maybe on straw floor roof. It doesn't matter. It will work.
Dr. Ghosh, which area? Just you mentioned about that.
He mentioned the middle part of India. Yes,
Middle
it's
part.
true.
Middle part means
Resource-wise, I mean, there may not be a very large
See,
reservoirs, but there are reservoirs also, and we have hilly regions. So potential-wise, we can have schemes developed for that regions also. But it's also true these regions are quite rich in biomass resources.
No, definitely.
And
All
solar is always
things,
there.
all the things are there. That is why I was requesting to name those areas. Please give us the name to those areas. If you,
Sir, can I?
As I mentioned,
No,
region-wise,
sir,
region-wise
can I?
planning is very,
why
very
are you not spelling out the name of the township or name of the city or name of the district or name of the state? You tell whether it is MP or UP or, this central India means either a part of MP or a part of UP or a part of, basically
Maharashtra.
Maharashtra or, even the Hyderabad to some extent, Andhra Pradesh to some extent to central India. Now you tell me any district, I can give you the, possibility what can be done there. It is
Sir,
not,
sir,
nowhere solar can be ruled out.
no, sir, can I tell something? Because there are a lot of remote villages in Jharkhand, basically where the grid, taking grid was very, very difficult. So that basically that the solar lantern and then solar home lighting system, those have been provided to them. So
Ideal. 25 years life. It's
yes,
ideal. Very,
and
very low
also
cost.
solar
Very
street
low cost.
light. For every 10 houses, there was a solar street light was given, and all the places like schools and the club and any other places where solar light was placed. So that is the way they have given. Yes, the biomass, because I've seen the long back, even Gosaba, when we visited, that time Dr. Gon Chaudhary was there as a, so I went with him. So we have seen that 500 kilowatt,
Kilowatt, 500 kilowatt. Yeah.
plant, 100 to 5 into 100 kilowatt plant was operating with a basically energy plantation method, because forest department was giving the supply, because they are giving money for energy plantation. But that time that basically that is engine was diesel engine, was it was a dual fuel engine, it was available dual fuel. Afterwards, even with a producer gas based engines are available, so even 20% substitution of oil is not required. So this is one scope. But definitely the remote villages, still the government planning is to go for a solar home lighting, solar street lighting, and solar lantern. Those are the things. And distributed solar system is already, there's a policy.
Bamboo. Don't think, sir, don't think of steel.
Hmm.
Just bamboo structure. You make a bamboo structure and put your solar panels on that. It will work perfectly all right. This is my country. I know my country. Absolutely. No steel, no structure is required. But of course, when you go to the villages, you will find beautiful houses, better than cities. They are there. But you don't need anything. You need a bamboo structure, and to which not even a nail is required. You tie it with ropes and then you put your solar panel there. It will work.
Probably Achyuta,
Bye.
our planning was more into community scale development, but not individual development. We didn't promote to that extent individual installation. I mean, if we could give a subsidy or publicize subsidy that way, I mean, we could have individual installations everywhere, particularly remote villages. But what we had several community scale development, but promoted by certain government agencies. So they had other problems, other running issues. For example, this Gosaba itself also. In fact, there are other projects also. Jharkhand was pioneering in biomass based earlier gas based systems also. But solar wise, I mean, we didn't promote individual. I mean, as you was mentioning, in Europe or in America, you might be able
in
to
China,
find
in
individual
China,
installations,
in
rooftop
China,
systems.
all over China. Anyway, thank you very much, sir. I hope I'll retire after 9. Thank you.
I think we have taken too much time in discussing. Yes, sir.
No,
Chairman, sir.
it was interesting. It was interesting.
It's
Very
interesting.
interesting.
So should we call it a day now, or?
Yes, at the end, I would seek 2 minutes just for Thanksgiving.
Okay, so I'm handing over to, thanks to Prabodh, thanks to Dr. Maji, thanks to all the participants, Achyuta, Professor Bhattacharya. I cannot see Ashokda here, I mean, probably he has just left. And, from the side of IIST, Professor Ghosh, Professor Vidyut Pal, and all the faculty members, student volunteers, everyone. And I'm, sort of requesting Professor Ghosh to step in and take over the proceedings.
On behalf of the department and also on behalf of the Centenary Celebration Committee, also let me thank our today's speaker, Dr. Prabodh Kumar Maji, for taking time for this lecture and making this evening memorable with this lecture. Let me also take this opportunity to thank our today's chair, Professor Gautam Biswas, for taking time off from his busy schedule to present our today's speaker, introducing him and running and chairing the session for so long, for more than 2 hours. Thank you, sir. Thank you very much.
My pleasure always.
Thank you all members of alumni, my colleagues, students who joined today's session. Let us award this certificate of appreciation for our today's speaker, Dr. Maji. We will be sending this soft copy through email, and the hard copy we will try to send through post along with a memento. We might be having a picture of memento also if we have. So those,
Yes, we have finished this.
so these things we'll try to send to your address. If you have a city address, that will be very fine, because that way we can hand over. Otherwise, we have to arrange to courier, or you have to wait for the time when you might visit the institute. So that we'll talk to. I mean, we'll talk about that, how to arrange delivery of this thing. So thank you very much. So thanks everybody for joining the session.